In the last lesson, we were talking about parametric equations, introduced the idea of what a parametric equation is. Very quickly, quick review. A parametric equation is basically a pair of equations in this context where we have a parameter that determines x and a parameter, same parameter, that determines y. So each coordinate is determined by separate functions. So x is a function of t, y is a function of t, sometimes it's theta. So the last thing that was said in the previous lesson was this kind of random obscure thing about what a smooth curve is within the context of a parametric equation or parametric equations. And we saw, smooth, not smooth, smooth, not smooth, and smooth, and then endpoints. It's just a different issue altogether, but not smooth at these two because of this sentence that didn't make much sense out of context, and you're about to get some context for it. Basically, smooth curve unless the derivative of x and the derivative of y are simultaneously zero. And if they are both simultaneously zero, then you have this crazy not smooth curve thing going on. So now we're going to talk about what a derivative is of a parametric equation. And basically you take the derivative separately. You're going to find the derivative of y with respect to t, the derivative of x with respect to t, but then just in true slope form, true slope fashion, I guess you could say, you're going to do change of y over change of x. And it's really going to be that easy. So take the derivative of y, take the derivative of x, put the y part over the x part, and you're done. It's really that easy. The second derivative of these, different lesson, gets a little wacky, but let's just continue with what is relatively simple. So let's do it. So don't panic about the smoothness of the curve, but now we do have a little more context for that definition. What is the slope of the line tangent to the plane curve at t equals -1? So here is the function, let me not call it that. Here is the parametric equation, here are the parametric equations. And I want to know the slope at a specific t value. And so we are going to figure that out. First of all, let's take the derivative of y. So the derivative of y with respect to time would be, or t, we'll assume it's time, 3t squared minus 1. And the derivative of x with respect to t is 2t, just 2t. And so dy over dx is dy dt over dx dt. And you could say the dt's cancel out, you could, but the big idea really is you have 3t squared minus 1 over 2t. And that's what we have. Now, I'm not done because I want to know the slope of the line tangent to that plane curve at t equals -1. So let's find dy dx at t equals -1. And that's going to give me 3 times -1 squared minus 1 over 2 times -1. And so we're going to have 2 in the numerator, -2 in the denominator. We have -1. So just for a little more context, let's graph this. And I am currently in parametric mode. Just in case you forgot, you could press mode, go to parametric, press y equals, and we're going to type that in and that in. So x squared minus 2, t squared minus 2, and then t cubed minus t. And we're going to graph it. Now, when we graph it, if we just go to a default window, like if I go zoom standard, which is zoom 6, we have this. We're not really seeing what we need to see. And I need to know where t equals -1. So I'm going to press window. The t values don't go back too far. I'm going to go back to pi. I want to. It goes forward to pi. Usually they do these by default in increments of pi. That's just kind of what happens. So that's -2 pi, that's +2 pi. And now we have a little more context for it. Now we still don't exactly know what we're talking about. So you're like, what am I looking at? Well, you're looking at the graph of this, and I want to know the slope where t is -1. Well, where is that? It's not where x is -1 necessarily. It's where t is -1. So if you want to get really technical about it, just because I want to, I could find where that is, like exactly where that is. And I'll tell you right now where that is. So x of 1 is 1 squared minus 2, which is -1, and y of 1 is 1 cubed minus 1, which is 0. So at t equals -1, I'm pointing kind of in the wrong place. at t equals -1, the x value is -1 and the y value is 0. So we are indeed, coincidentally, dealing with a t value that matches our x value that also matches our slope. So at x equals -1 and then y equals 0, we're at this coordinate right here, and the slope is indeed 1. Now you could also make the argument that the slope would be -1 if you're coming around the other way. It's a thing. You could do that. What is the slope of the line tangent to the plane curve at the point 2, 6? Okay, well, 2, 6. Well, here's the deal. In this one, they told us the t value. In this one, they didn't. So I need to find the t value. I need to find, like, at what t value does this take place? So I could find 2, 6 on this graph, and 2, 6, you know, well, 2, 6. I was thrown off by that blinking cursor. That sounded like profanity. It wasn't that blinking cursor. But 2, 6 is right here, and the slope, well, I know it's positive something, but I don't know exactly what it is. But the thing is, I need, for my derivative, I need the t value. My derivative is based on t values. So I need to find out what t value makes x equals 2 and makes y equal 6. So we're going to figure that out very quickly. So 2 equals t squared minus 2. Which leads me to, we'll add the 2, 4 equals t squared, which leads me to, I didn't write my equations down, I'm writing them sideways with arrows. Don't just keep putting equal, because they're not. Which means 2, t is equal to plus or minus 2, positive or negative 2. All right, let's solve this one. So 6 is equal to the y value, which is equal to t cubed minus t. T cubed minus t. Yeah, good luck solving this one by hand. Like, really, good luck with that. Don't even try it. So what I'm going to do for that is just kind of cheat a little bit. We're going to go to y equals, and we're actually going to go to y equals, not like parametric mode. So switching modes again, function. I want to find, going old school here, we're going to find where t cubed minus t, or in this case, x cubed minus x, I'm just using an old tool for a new thing, matches with 6. Zoom 6, there we go. Zoom 6, because that's zoom standard, and I'm about to find out that x value, which is going to be the t value that solves this. So second calc, point of intersection, first curve, enter, second curve, enter, guess, enter, x equals 2. Now, you might say, well, haven't you already found it? Well, yeah, but I didn't really narrow it down. Was it 2? Was it -2? Could have been either one of them. So let's rewrite the question, actually. What is the slope of the line tangent to plane curve where t equals 2? Okay, now it's easy. Like all the stuff that we just did, that right there got replaced with this right here. We found out how this corresponds to that, and then we'll move on from there. So let's grab a different color pen. Let's go purple, just for fun. And then we'll drop it, and it did not write on my pants. That's good news. So dy, I know you were concerned. Oh my goodness. dy dx at, oh, we're about to lose our purple. T equals 2. Come on, I can finish this problem with it. 3 times 2 squared minus 1. I'm going back to this derivative here. Over 2 times 2. And that's going to give me 12 minus 1, so 11 over 4. 11 over 4, which kind of makes sense, really, when you look at the graph. Going back to parametric mode now. When I look at the graph, at the point 2, 6, that slope looks to be about, so it's positive for sure, and this graph is a little bit stretched wider than it is tall. So adjusted for that, it would be about 3-ish. Okay. All right, what is the equation of the line? Whoa, pause right there. The equation of a tangent line, that requires this. Haven't even finished reading the problem yet, but we've already identified a process to begin. What is the equation of a line tangent to the plane curve at t equals 1? Okay, well, here's the deal. I need the slope at 1, and I need the x and the y value at 1 as well, at t equals 1. So let's find them. Switch colors again. So x of 1 is, well, we just did this a second ago in our heads, but 1 squared minus 2, which is -1. And then y of 1 is 1 cubed minus 1, which is 0. So now I know the x1 and the y1 values, right? So this is y minus 0. Why did I put that? I don't even know. X minus -1, there's that. And then the slope at t equals 1 is 3 times 1 squared minus 1 over 2 times 1. And that's going to give me 2 in the bottom and 2 on the top and a 1 and a 1 and a 2. And so this is it, actually. We could stop here, but let's go a little further. That is the equation. So if I was somehow able, with the technology I have on this calculator, to graph parametric and rectangular, we'll call it, just basic functions, in the same coordinate plane, then where t equals 1, which would correspond to the point -1, 0, we would have this line right here.